Today we're exploring one of the most fascinating mysteries in cognitive science, the intelligence ceiling paradox. This is a phenomenon that has puzzled researchers for decades. Here's the core observation. Below an IQ of approximately 120, we see a strong positive correlation between intelligence and achievement. The line goes up steeply. But above this threshold, something remarkable happens. The correlation essentially flatlines. Higher IQ stops being a reliable predictor. This immediately raises a critical question. Why does this threshold exist? What changes at this intelligence level? Above IQ 120, we observe enormous variation in real-world outcomes. Some individuals with IQ 130 produce groundbreaking work, while others with IQ 160 may produce nothing exceptional. The variance increases dramatically. Look at this scatter plot of IQ versus patents filed. Each dot represents a scientist. Notice the massive spread. Here's someone with IQ 125 who has filed 90 patents. And here's someone with IQ 160 who has only 16 patents. This is the paradox made visible. Let's quantify this more precisely. We can calculate the correlation coefficient in different IQ ranges. Below IQ 120, the correlation coefficient R is approximately 0.7. This is a strong positive correlation. Above IQ 120, the correlation drops to approximately 0.2. This is barely significant. The predictive power of IQ essentially vanishes. So what explains this dramatic shift? This is where we enter the realm of non-cognitive factors. Intelligence is necessary but not sufficient. One leading theory is the cognitive sufficiency hypothesis. It proposes that there's a minimum intelligence threshold needed for complex creative work. Think of it like a gate. Below the threshold, you don't have the cognitive machinery needed. You're filtered out. Above the threshold, you have sufficient cognitive ability. Now other factors take over. You're in a new game entirely. Let's do a back-of-envelope calculation to understand the magnitude of this effect. Consider the population of scientists with IQ above 120. Approximately 10% of the population has an IQ above 120. That's roughly 1 in 10 people. Only about 0.4% have an IQ above 140. That's 1 in 250 people. The ratio is 25 to 1. There are 25 times more people with IQ between 120 and 140 than above 140. Here's the striking observation. Most Nobel Prize winners have IQs in the 120 to 140 range, not above 140. Despite being 25 times less common, the ultra-high IQ group doesn't dominate exceptional achievement. Now let's systematically examine the non-cognitive factors. The first is conscientiousness. This is one of the big 5 personality traits. Consider two people. Person A has IQ 160 but low conscientiousness. They work 3 hours per day inconsistently. Person B has IQ 130 but high conscientiousness. They work 12 hours daily with discipline. Over years, Person B accumulates far more high-quality work. We can write a simple model. Output is proportional to IQ times time invested times quality of focus. All 3 factors matter multiplicatively. For Person A, let's say output equals 160 times 3 hours times 0.5 focus quality. That's 240 units. For Person B, output equals 130 times 12 hours times 0.9 focus quality. That's 1404 units. Nearly 6 times higher despite lower IQ. The second critical factor is openness to experience. This trait predicts creativity and intellectual curiosity. Low openness creates a restricted idea space. The person explores a narrow region. High openness expands the search dramatically. They explore diverse domains, make unexpected connections, and find novel solutions. Einstein is a perfect example. His IQ was estimated around 160, certainly high but not unprecedented. His openness was extraordinary. He studied philosophy, music, and visual thinking. These diverse inputs fed his physics insights. The third factor is intrinsic motivation. This is the drive that comes from internal satisfaction, not external rewards. Extrinsic motivation is driven by money, status, and recognition. This typically burns out. Intrinsic motivation comes from curiosity, desire for mastery, and flow states. This can sustain effort for decades. Malcolm Gladwell popularized the 10,000-hour rule. But hours alone aren't enough. You need 10,000 hours of deliberate practice driven by intrinsic motivation. Without that internal drive, people quit long before mastery. The fourth factor is resilience and grit. This is the ability to persist through failure and setbacks. Real progress doesn't follow a smooth curve. It's filled with setbacks, failures, and apparent regression. These red dots mark major failures. Low-grit individuals quit here. High-grit individuals persist through these valleys. Thomas Edison famously said he didn't fail 10,000 times, he found 10,000 ways that didn't work. His IQ was estimated around 145, good but not extraordinary. His resilience was off the charts. The fifth factor is social and collaborative skills. Modern science is increasingly collaborative. Lone genius is mostly a myth. Compare two scenarios. On the left, a high IQ individual working in isolation. On the right, a network of people with diverse skills collaborating. The network produces far more innovation. Ideas cross-pollinate. Weaknesses are compensated. The Manhattan Project exemplifies this. It wasn't dominated by the single highest IQ person. It succeeded through collaboration among scientists with complementary skills. Oppenheimer's leadership and social skills were as important as his physics knowledge. Now let's construct a mathematical model to formalize these ideas. We'll express achievement as a function of multiple variables. Achievement A is a function of intelligence I, conscientiousness C, openness O, motivation M, resilience R, and social skills S. We can model this as a product with exponents. Each factor is raised to a power that represents its importance. Here's the key insight. The exponent alpha on intelligence decreases dramatically above the threshold. Below IQ 120, alpha might be 0.8. Above IQ 120, alpha might drop to 0.1. Below the threshold, alpha equals 0.8. Above the threshold, alpha equals 0.1. This captures the diminishing returns. Meanwhile, the other exponents remain substantial, ranging from 0.3 to 0.5. These non-cognitive factors don't diminish in importance. Let's plug in some numbers to see this model in action. We'll compare two hypothetical individuals. Person X has IQ 160 but low non-cognitive factors, all at 50 on a 100-point scale. Person Y has IQ 130 but high non-cognitive factors, mostly at 90. For person X, achievement equals 160 to the 0.1 times 50 to the 0.45 times. Let's calculate each term. 160 to the 0.1 is about 1.58. And 50 to the 0.4 is about 5.62. Raising that to the fifth power gives 5,616. Multiply by 1.58 to get approximately 8,873. For person Y, achievement equals 130 to the 0.1 times 90 to the 0.44 times 85 to the 0.4. 130 to the 0.1 is about 1.55. And 90 to the 0.4 is about 7.68. Multiply by 85 to the 0.4, which is 7.22. This gives approximately 39,060. Person Y achieves 4.4 times more than person X despite having an IQ 30 points lower. This model captures the essence of the paradox. Above the threshold, non-cognitive factors dominate. Now we must address environment and opportunity. Even with high IQ and ideal non-cognitive traits, achievement requires the right environment. Left side. Poor resources, no mentors, no funding, no network. Potential is wasted. Right side. Rich resources, great mentors, ample funding, strong network. Potential is realized. Environment acts as a multiplicative factor. Ramanujan is an extreme case. Extraordinary mathematical genius, estimated IQ above 180. He worked in isolation in India with minimal formal training. Once Hardy brought him to Cambridge, his productivity exploded. Environment unlocked his potential. Let me pose a provocative question. Can extremely high IQ sometimes be a burden? Does it create challenges that reduce achievement? There are several potential burdens. Difficulty relating to others, boredom with standard education, perfectionism that prevents completion, overthinking that leads to paralysis. Top. An IQ 180 person sees 20 different approaches to a problem. They spend months analyzing which is theoretically optimal. They never finish. Bottom. An IQ 130 person sees 3 approaches, picks one quickly, and executes. They complete the project. This relates to satisficing versus maximizing. Satisficers pick a good enough solution and move on. Maximizers seek the absolute best. Very high IQ can push people toward maladaptive maximizing behavior. Let's dig deeper into creativity specifically. The paradox is particularly pronounced for creative achievement. Why doesn't higher IQ predict greater creativity above the threshold? Convergent thinking takes many ideas and narrows to one solution. This is what IQ tests measure. Divergent thinking takes one prompt and generates many ideas. This is core to creativity. IQ above threshold doesn't predict divergent thinking ability. The remote association test measures creative cognition. You're given 3 words and must find a 4th that connects them. For example, cottage, Swiss, cake. The answer is cheese. This ability doesn't strongly correlate with IQ above 120. Creative breakthroughs often involve incubation and insight. You work on a problem, get stuck, step away, and suddenly the solution appears. This process has a biological basis. Focused mode. Prefrontal cortex is highly active, working deliberately on the problem. You get stuck. Incubation. You step away. The default mode network becomes active, making remote associations unconsciously. Suddenly, insight strikes. The solution emerges. Interestingly, very high IQ individuals sometimes struggle with this process. They're so good at focused analytical thinking that they don't let go and allow incubation. They keep grinding consciously when they should step away. There's another crucial element, the Matthew effect. Success breeds success. Small early advantages compound over time into massive differences. Green line. Someone with high non-cognitive factors grows at 15% per year. Blue line. Someone with higher IQ but lower non-cognitive factors grows at 10% per year. Initially, they're similar. After 30 years, the gap is enormous. Compounding is exponential. Output as a function of time equals initial output times e to the RT, where R is the growth rate. Small differences in R create massive differences over decades. The ratio after 30 years is e to the 1.5, which is approximately 4.5. The high non-cognitive person produces 4.5 times more despite starting with less raw intelligence. Another mechanism is citation networks. Scientists who publish early and get cited become more visible. This creates a feedback loop. Scientist A publishes a paper. It gets 5 citations. Those papers cite it again. The citation count grows. More visibility leads to more citations. This network effect amplifies early success independent of IQ. We must acknowledge the role of luck and timing. Being in the right place at the right time matters enormously. Alexander Fleming discovered penicillin by accident. A contaminated petri dish led to the observation. His preparation and knowledge allowed him to recognize the importance, but luck initiated the discovery. Preparation plus opportunity equals breakthrough. Preparation requires IQ above threshold plus non-cognitive factors. Opportunity includes luck, timing, and being exposed to the right problem. Both are necessary. Let's synthesize everything we've learned into a comprehensive framework for understanding the intelligence ceiling paradox. Stage 1. Below IQ 120, intelligence is the limiting factor. You simply don't have the cognitive capacity. IQ predicts achievement strongly. Stage 2. IQ 120 to 130, a transition zone. IQ still matters but non-cognitive factors become increasingly important. The predictive power of IQ weakens. Stage 3. Above IQ 130, non-cognitive factors dominate. Intelligence is necessary but not sufficient. The variance is driven by personality, motivation, environment, and luck. 3 stages visualized. Left. Red zone. IQ below 120. IQ limits achievement, strong correlation. Center. Orange zone. IQ 120 to 130, transition period, medium correlation. Right. Green zone. IQ above 130, non-cognitive factors limit achievement, weak correlation. What are the practical implications of understanding this paradox? How should we think about education, hiring, and talent development? First implication. Selection processes should be multidimensional. Using IQ or SAT scores alone above the threshold is ineffective. We need to assess conscientiousness, creativity, resilience. Second implication. Education should explicitly develop non-cognitive skills. Currently, most education focuses on cognitive skills. We need to teach grit, collaboration, creative thinking. Third implication. Create environments that nurture diverse talents. Provide mentorship, resources, networks. Environmental interventions may have higher return on investment than further cognitive training. Fourth implication. Individuals should develop self-awareness of their non-cognitive strengths and weaknesses. If you have high IQ but low conscientiousness, this is your bottleneck. Address it directly. Let me pose some open questions that remain unresolved in this field. These are active areas of research. Question 1. To what extent are non-cognitive factors trainable versus fixed? Can we teach grit? Can we increase openness? Some evidence suggests yes, but the effect sizes are debated. Question 2. Does the threshold vary by domain? Is it 120 for physics but 140 for pure mathematics? Different fields may have different cognitive demands. Question 3. Is there cultural variation? Do collectivist cultures show different patterns than individualist cultures? Social factors may modulate the relationship between IQ and achievement. Question 4. Can we develop better predictive models? If we assess all these factors, can we predict exceptional achievement? Or is there irreducible uncertainty from luck and emergence? This paradox raises a deeper philosophical question about human potential. What does it mean to be intelligent? Is intelligence just IQ, or something much richer? Narrow view. Intelligence equals IQ, a single number. Broad view. Intelligence is multidimensional, including cognitive ability, creativity, emotional intelligence, grit, wisdom, and social skills. The intelligence ceiling paradox is strong evidence for the broad view. If IQ were the essence of intelligence, it would predict achievement at all levels. But it doesn't. Therefore, intelligence must be richer than IQ. Let me conclude by summarizing the key insights from this deep dive into the intelligence ceiling paradox. Key insight 1. The threshold effect is real, robust across multiple studies and domains. Above IQ 120, the correlation between IQ and achievement drops dramatically. Key insight 2. Non-cognitive factors conscientiousness, openness, motivation, resilience, and social skills become the primary drivers of achievement above the threshold. Key insight 3. These factors interact multiplicatively. Weakness in one area can bottleneck achievement regardless of IQ. Excellence requires balance across multiple dimensions. Key insight 4. Environment and luck play crucial roles. Talent without opportunity produces nothing. The Matthew effect amplifies small early differences into large outcomes. Key insight 5. Understanding this paradox has profound implications for education, hiring, and talent development. We must assess and develop the whole person, not just cognitive ability. The intelligence ceiling paradox, ultimately, is not really a paradox. It's a reflection of the complexity of human potential and achievement. Intelligence provides the foundation, but the structure built on that foundation depends on personality, effort, environment, and chance. Exceptional achievement is rare precisely because it requires alignment across all these dimensions. This is what makes it exceptional.